Good evening. So in this particular video, I'm going to discuss the simulation of a CSTR reactor in Aspen Hysys. Let me show you the PowerPoint. Okay, so in this tutorial, we're going to discuss isomerization in a CSTR with Aspen Hysys. So this is the reaction that we're going to simulate. This is between cis-2-butene and trans-2-butene. So if you still remember your organic chemistry, when you say cis indicates that the hydrogen are on the same side in a double band containing molecule. Tapos the methyl group is on the same side also. Tapos it is spontaneously converted to trans-2-butene. So in trans, the hydrogen are on the opposite side. So structurally, trans-2-butene is more stable compared to cis-2-butene because the electron clouds of the methyl group uh, will not both have negative charge, so they will not be structurally hindered. So this is more stable. So this is the equation for a first order reaction. We're going to assume our research has found out that this reaction is a first order reaction. So if you have a first order reaction, R sub A is conventionally we call this negative KCA, pero siya ginawa niyang KCA. So mamaya makikita niyo doon na lang niya i-adjust dun sa balance, sa balance equation. Kasi ganito yung kanyang convention. Pero normally kay Pagler at saka kay Liebenspiel, this is supposed to be negative KCA kasi A refers to the reactant. So that's why dCA dt is equals to negative RA or negative KCA. And then CA is equals to NA divided by B. B is the volume. Okay, of course, I hope you're still familiar with this equation sa kinetics. Okay, RA is moles of reactant becoming product per unit time, per unit volume. So this is the time until any given conversion of reactant is independent of reactant size. So ito namang RA na to, itong moles of reactant becoming product per unit time, per unit volume. Totoo ito sa CSTR at saka sa PFR. Medyo mag-iiba lamang siya sa PBR kasi sa PBR per unit weight siya. So ito namang time until any given conversion of reactant is independent of the reactor size sa batch to. Sa batch yung sinasabi niya. Actually, kahit anong reactor, tama din to. So that's why yung technique natin sa pag-calculate ng volume, gumagamit tayo ng residence time na concept. So kung tandaan nyo pa, yung residence time is basically volume of the reactor divided by volumetric flow rate. So kung na-solve natin yung residence time, tapos alam natin yung volumetric flow rate, you can easily find this out using Aspen. You can size the reactor. Ganun lang naman yun. Unahan nyo pa kinetics nyo. Okay, so ito yung balance natin sa CSTR. CSTR is continuously stirred tank reactor. So we're going to assume perfect mixing in the tank. Effluent stream has same composition as the tank. Yung effluent yung lumalabas. Effluent yung lumalabas. So Q in times CaO, ito yung pumapasok ng stream. Yung Q in dito, ito yung conventionally we call this B. B ang tawag natin dyan dito sa Q in na to. Yung volumetric flow rate. minus Q out. So ito yon times CA. I hope you still remember your kinetics. Ito, plus ano tayo. Ang convention natin dito is plus RA times B, capital B, ano, volume of the reactor. So nag-negative siya dito kasi yung RA niya, if you still remember, is equals to KCA. Hindi ganun yung convention natin. Ang convention natin, negative KCA. Yung change ng volume sa tank is Qn minus Q out. Pag equal itong dalawa, zero lang to. Ano? And then, pag steady state, so zero din to. So pag steady state is defined as zero yung change sa level ng reactor at saka yung change sa concentration ng A dito sa reactor. So steady state, all derivatives are zero. All time derivatives are zero. These two are zero. So you are asked to solve for 90% conversion in a CSTR of that reaction. Ano? Yung cis-2-butene to trans-2-butene. Tapos report the residence time required. The rate of the reaction is 0.23 per minute. So tingnan nyo to, ano? Per minute. So clearly the reaction is first order. Kasi diba pag multiply mo to ng molarity, you will have moles per liter per minute. So, first order siya, ano? So use Aspen Hysys to verify the answer. So first, let's try to calculate the ano. Halimbawa, manually kinalculate natin yung residence time. So let's start with the ano, with the equation ng CSTR. So draw muna natin yung CSTR. Down ko yung annotation. Okay. So drawing natin yung CSTR system. Ang mukha din lang nung kanina. No? So ito yung initial concentration ng A. Tapos ito yung flow rate natin. Para medyo kamukha kay Pagler at kay Liebenspiel. Tapos ito yung final concentration natin. Tapos i-assume natin steady state. Yung pa rin yung volumetric flow. Tapos ito yung volume na reactor. Ano? Yung capital B. So, initially, yung pumapasok, okay, CaO times B, this is moles per liter, no? This is moles per liter. This is liters per minute. So, pag pinag-multiply nyo silang dalawa, can imagine, ano, magka-cancel out yung liters. So, liters per, moles per minute, ano? Ma-minus natin yung lumalabas. Okay, tapos add natin yung ano, yung volume times dun sa rate ng reaction. So ang logic nitong third term, ito yung generation kasi. Ang unit kasi nito ay moles per liter per minute. So pag multiply nyo siya ng liter, magiging moles per minute na rin. So yung tatlong term, para sila ng units. So, yun yung isang justification ng equation. Tapos assume natin na steady state yung system. Okay? Tapos kasi yung given sa atin ay conversion, 90% conversion. So siguro kailangan nating para ma-solve natin to, yung tau naman B over V lang naman yun. Ano? Para ma-solve natin to, we need to convert all the concentration in terms of conversion. So gamitin natin yung equation ng CaO, Ca is equals to CaO 1 minus hexabrate. Gamitin natin to, ano? So we're going to replace all Ca, no? Remember, ang RA ay negative KCA din, ano? Okay. So ito, yung first term, CaO pa rin yan. CaO times B. Hindi yung babago. Tapos yung second term, that's going to be CaO. CaO 1 minus XA. Okay. Times B. Tapos yung third term, magiging negative. Yung RAKCA, So K. Tapos CA yun. So palitan din natin ng CaO 1 minus XA. tapos times the volume of the reactor. Steady state is equal to 0. I hope you can follow. Ano? So what you can do is you can factor out CaO tapos lipat ko sa kabila. Mawawala na yung CaO. So it's like canceling this. So, wala na tayong CaO. So ito na lang yung ating ano no, yung class equation natin. As you can see, it's solvable, no? You can calculate the residence time by simply transposing this term to the other side of the equation. Transpose natin yung last term sa kabila. Tapos ang matitira dito ay B minus 1 minus XA times B. Sa kabilang side, we have K 1 minus X sub A times B. Yung B na malaki, ano? Yung volume. So, kasi ang residence time natin ay B over B, we'll just factor this out. Kapag pinactor out natin yan, ang mangyayari dito sa term na to ay magiging na lang siya, ano, B 1 minus 1 plus X sub A. Diba? 1 minus 1 plus X sub A. Pag din, ano nyo yung, ano, dinistribute nyo yung negative. Okay, so as you can see, this will cancel out. 1 minus 1 will cancel out. So may B na lang tayo doon, tapos may XA dito. Sa kabilang side naman ay 1 minus K, 1 minus XA. So, if you're going to transpose small letter b to the other side, you will have the tau, ano, equation for tau, explicit equation for tau, which is b over b. So b over b is XA divided by K times 1 minus XA. So if you're going to substitute the given, XA is 0.9, tapos K is 0.23 per minute, tapos 1 minus 0.9, and then just use your calculator. You're supposed to get ano, 39.13, ano? 0.9 and 23 times 0.1. 39.13. So yun yung papalabasin natin sa Aspen Hysys. Ano? Yung residence time na 39.13. Okay? So basically we're going to solve the same problem. Aspen Hysys. So let me share the Aspen Hysys. Okay, so this is our Aspen Hysys. First, I'm going to add the components. I'm going to open a new case. Tandaan nyo pa, no? Okay, mag-open ng new case. Okay. And then I'm going to add the two components, cis-2-butene. Dapat walang space para mag-appear siya. Ito, ano? Okay, dial to. Bakit wala? Check ko lang sa tutorial paano ginagamit. Common name ng C-stability. Anyway, probably simulation name. Yun. Lipat nyo lang sa simulation name. Ano? Pag hindi nyo makita-kita yung cis-2-butene. Madali magano sa cis-2-butene. And then trans-2-butene. Tingnan natin kung magkakaproblema. Yung trans na tatanda ko, TR2 lang yan. Ilipat ko sa simulation name. Ano? Ayun, madali lang. Ano? Okay. So that's it. And then, ang gagamitin natin fluid package ay NRTL. Okay. Iwan na lang natin sa ideal muna, no? Hindi ko matandaan kung ideal yung anyway, basta ideal lang gagamitin natin. And then that's it. Pwede na tayong ano, green na to, di ba? Ano, green na. Pwede na tayong punta sa simulation. Let's go to simulation. Okay. And then, magdadrag na tayo ng reactor, CSTR reactors. Ito. Ito yung CSTR reactor. Okay, so just double click this para mapasok natin yung mga ano, no? Mga data. Pangalanan muna natin yung stream natin. So, feed muna. Yung feed natin ay yung cis-2-butene, ano? Pangalanan lang natin ng, you can name this as 1 para mabilis. Tapos, this is BOP, yung vapor product, and then this is your liquid product. Okay, and then I think isothermal yung reaction. No? So, mag-maintain tayo ng temperature, 25 degrees Celsius. So, lagyan natin ng energy. Kung gusto niyo maging isothermal, palagi namang isothermal yan. Lagyan niyo ng pangalan yung energy. Pero kung ayaw niyo gawing isothermal, huwag niyo lagyan ng ano. Hindi ko matandaan doon sa tutorial kung nilagyan niyo ng pangalan. Check natin, ano? Sa tutorial, anyway. Nilagay, huwag na lang. Parang hindi nga ata siya nilagay. Tanda ako. So, bale, hindi ano to, no? Hindi isothermal. Pero ano, generally, in practice, dapat isothermal ang reactor. Okay? Next is, alam natin yung, let's go to worksheet, ano? Alam natin yung composition ng pumapasok. Yung composition ng pumapasok ay pure cis-2-butene. So, this is 1.0 cis-2-butene. Yun. Tapos, okay. Okay, and then, let's go to conditions. So, from the tutorial, yung temperature niya ay, yung feed ay 25 degrees Celsius. Tapos, ang kanyang pressure ay 10 bar. Okay. Ang kanyang molar flow ay 1 kg mole per hour. Nagana na siya, ano? Nag-converge na siya. So I think yung sa reactor din, 10 bar din yung pressure. Both sa liquid at saka sa product. Okay. Kalimutan ko. Actually, before you proceed to the simulation, I think you should add a reaction, no? Before you proceed to simulation. Pero pwede niyo naman balikan. So, add natin yung reaction. Okay. So, add reaction. Just click add reaction. Tapos, this is a kinetic reaction. Pag CSTR kinetic, ano? Tapos, add reaction. Tapos, just double click the reaction 1. Okay. So, ang component natin ay cis-2-butene at saka trans-2-butene. Ano? Tapos, stoichiometric coefficient niya. Pag reactant, negative 1. Pag reactant ay negative. Tapos, pag product ay positive. Okay? Unless may given, huwag nyo na itong baguhin, itong order. Pero pag merong given, baguhin nyo ito. Ano? Forward order at reverse order. Okay? Yung ano natin, yung conversion natin ay based sa conversion ng cis-2-butene. Ito yung A natin. Ano? Sa liquid phase. Pwede nyo rin ilipat ito sa overall. Tapos kasi per minute tayo, kailangan natin yung ilipat ito sa pound mole. Nila kasi may per minute eh. Pound mole lang. So, tingnan nyo isa-isa. Ito lang yung may per minute. So, dapat itong concentration nyo, pound per cubic feet. Tapos yung A is 0.23 per minute. Okay. You can use E as 0. You can enter 0 sa E. 0 din sa B. And then that's it. So, as you can see, ano na siya. Ano? And then you close this one. Tapos, all you need to do is add this to the fluid package, yung reaction 1. So, just add this to FP. Tapos, add set to fluid package. And then, mawawala, kita nyo, mawawala na dito yung exclamation point. Ano? So, ano na yun? Nag-converge na siya. Or okay na siya. No? And then, you can go to simulation. Ito yung simulation natin, CSTR 100. Pag dinouble click, napasok na natin yung temperature at saka pressures. Ano? Tapos, pasok natin yung reaction niya. Gagamitin natin siyempre yung reaction 1. Ano? Set 1. Okay. Tapos, let's go to design. Dun sa design, go to parameters. Tapos, initially kasi mag-a-adjust function tayo, no? Palalakihin natin yung volume hanggang maabot yung 90%. So, ang initially, yung pinakamaliit na volume sa industry ay 5 liters. So, lagay nyo dito sa initial volume niya, 5 liters. So, 5. Tapos, palitan nyo ito ng liters. Tapos, yung liquid volume, kasi nga puro liquid siya, 100. 100%. Ano? Kita nyo nag-convert na siya. Ano? Kasi naglagay na agad kayo ng volume. Tapos meron siyang reaction. Meron siyang K. Ano? So, makakalculate. As you can see, makakalculate nyo na lahat. Makakalculate nyo na. Pero hindi pa tayo tapos. Kasi gusto natin 90% conversion. Yung volume na yon, it corresponds to the smallest possible industrial reactor. So, palalakihin pa natin yun para makuha niya yung gusto nating conversion. As you can see, tinan nyo. Parang almost 50% pa lang yung conversion natin. Ano? Nasa 43. Nasa 43% pa lang. Kaya gusto natin 90%. So, para mag-adjust yung conversion, gagamit tayo ng adjust function. So, just drag an adjust function. So, adjust function ito. Ano? Drag and drop an adjust function. Tapos double click nyo. So, ang i-adjust natin yung volume ng reactor. Ano? CSTR 100. Tapos itong tank volume. Yun yung i-adjust natin. From 5 liters, dahan-dahan palalaki niya hanggang maging 90%. Tapos sa target variable, hanapin natin yung sa liquid product. Ano? Pwedeng sa liquid product, ito lang dito yung yung percent conversion. Hanapin lang yung percent conversion. Pag wala dito, nasa reactor. Sige, nasa reactor. Ito. No? Select. Tapos take note percentage to. So, ang value dito, mga 90, 95, gano'n, ano? Percentage yan. Hindi 0.9, ha? So, ang lalagay natin dito, 90%. Okay, so para ano, hindi na kayo paulit-ulit, lagay niyo yung number ng iteration, lipat gawin yung 1,000. Gusto niyo yung number ng iteration. Tapos, simply click start. Converts na siya. Ano? Okay? So, actually, pag nag-ano kayo, nag-adjust function kayo ng ganun, ang makukuha nyo, yung actual volume ng reactor. So, as you can see, pag chinek nyo, pumunta kayo sa design, sa parameters, makikita nyo, hindi na 5 liters yung reactor nyo. Ano na, 63.86 liters na. No? Lumaki na siya. In-adjust nyo na. So, kasi nga gusto natin i-confirm yung 39.13. So, if you still remember, ang residence time, volume of the reactor divided by flow rate. So, gagamit tayo ng spreadsheet. Parang Excel lang to. Ano? So, just double click this, tapos punta tayo sa spreadsheet. Yung una, dito natin lalagay yung volume ng reactor. Type nyo lang, volume of reactor. Tapos sa A2, dito natin lalagay yung volumetric flow rate. Okay? So ito yung capital B, ito yung small letter b. Tapos yung hinahanap natin, residence time. I hope you can understand what I'm trying to do. What I'm trying to do is I'm going to use a spreadsheet, parang Excel, ano? Tapos dito papasok yung volume of the reactor, dito papasok yung volumetric flow rate. Tapos isosolve natin dito sa B3 yung residence time. So B1 over B2. So ito yung retrieve natin. I-right click nyo lang to, itong space na to, i-right click nyo lang. Tapos mag-a-add kayo ng variable. Add import variable. So, ang gusto natin dito ay yung volume of the reactor. So, dito rin yan, ano? Hanapin nyo lang yung volume of the reactor. Let's go to letter B, ano? Ito, volume. Ano yung volume? Vessel volume. Vapor volume. Ano bang ibang volume? I think the liquid volume and the volume of the reactor are the same. Pero check ko rin natin. Phase volume. Yun, tank volume. I think this is better. That's much better. Ano? So, the tank volume. Okay. So, yun yun. Okay. And then you're done. Ito yun. Tapos volumetric flow rate. Ganun ulit. Right click. No, right click this B2. Tapos add import variable. So, probably you can go to CSTR 100. Hanapin nyo lang dito yung volumetric flow rate. So, liquid volume flow. That could be it. Pero check na rin, baka meron pang mas exact. Puro vapor na to, ano. I think that's it, no? So, ito, liquid volume flow. Done. So, what we're going to do is we're going to divide volume of the reactor with the volumetric flow rate. So, ito, ano lang yan, ano? Parang Excel din lang. Equal, tapos B1, type in nyo lang, tapos divided by B2. Okay, tapos enter. This is per hour, no? Per hour siya. So, para maging per minute, multiply pa natin ng 60, ano? So, times, I think times is star, tapos 60. Hindi siya exactly 39, ano? Tama to. Ito. Baka hindi siya liquid volume flow. Let's try another, ano. the liquid product. Baka meron ditong volumetric flow na mas kamukha ng nasa tutorial. Pero malapit naman, ano? Parang masyado. Pa rin. Probably this is ano, yung, I think this is error to ng ano. Yung difference ito ay dun sa fluid package. Siguro hindi siya ideal. Ano? Nag-RK siya. Let's try to change the fluid package to RK. Ngayon natin kung nagbago. No? Dito. Konti lang naman yung dito. So let me check the tutorial. Check this with another variable. Wala naman tayong in-assume doon sa ano. Tama yung na-calculate natin kanina. Volumetric flow rate. Ito, master component volume flow. Probably this is it. Master component volume flow. Ano? Oh. Very specific component talaga. Not that one. We want the total volumetric flow. Kasi dun sa So 39.13 kanina. Base siya sa ano? Pwede rin. I-base natin sa ano? Sa cis-2-butene. Ito, total component volume close. $41.68. Pag imagine nyo kasi, in-assume natin equal yung dalawa. Pumapasok at saka yung lumalabas. So, probably sa simulation talaga, hindi talaga sila equal eh. Kaya, ito iba to. Ano? So, halimbawa, dun tayo, ito yung incoming flow. Ano? Dun tayo sa incoming flow. Halimbawa, ito yung ginamit nating volumetric flow rate. Ito, per second na to. So, dapat divided by per minute ito. Ano? It's the difference between the unit. Dapat divided by. So, ito pag ano, pag sa feed mo binase. Pag sa product mo naman binase, 42.29. Pag sa product, so yung product is liquid product. Ayun. Actual liquid product, yung pinag-base, na 39.13. So, kasi doon sa solution natin, kung natatandaan nyo, in-assume natin na equal yung initial volumetric flow rate at saka yung final volumetric flow rate. Kaya nag-iiba-iba to kasi hindi naman talaga equal yung dalawang volumes. No? Iba yung volume ng pumapasok, iba yung volume ng lumalabas in actual simulation. So, yung sa tutorial, binase siya doon sa lumalabas, doon sa product. Kaya 39.13. Okay? So, that's how to do the CSTR. I hope you follow the tutorial. Ano? Anyway, just try to follow the tutorial na I earlier uploaded. So see you in the next video. Probably I'm going to discuss PFR and then we'll have our midterm. Ano? Probably midterm is on Thursday. Let's go back to Thursday. Midterm will be on Thursday 1 p.m. So 3 hours 1 to 4 p.m. Ano? Thursday 1 to 4 p.m. Ang coverage ng midterm natin ay distillation, shortcut at saka rigorous. Tapos CSTR, reactor at saka PFR, reactor. So see you in the next video.